Alright guys, welcome back. In today's question, we're going to be solving another problem from chapter 4 of your Johnston textbook, and we have a light bar 80 that is suspended from a cable BE and supports a 50 pounds block at point C. The two ends of A and D of the bar are in contact with frictionless vertical walls, and we need to determine the tension in the cable BE and the reactions at point A and D. So as always, we're gonna start with the free body diagram, but before that, please make sure to subscribe to the channel. That's gonna help us to grow the channel faster and reach out to more students who need some help with this course. And let's get started. So we have this bar 80 that has a 50-pound block at point C. So we have 50 pound in here. We have two reactions at A and D, and since it's a frictionless surface, the only force that we have is the normal force, which for point A will be in this direction, and for point D we'll have this. And in here we have the tension in the cable, let's call it T, and that's pretty much all the forces that we have for the free body diagram. So once again, since there is no friction at the wall, we don't need to consider any vertical force at point A and D. So if that's the case, we can start with our equilibrium equations, which are sum of all forces equals 0 and sum of all moments equals 0. So looking at the free body diagram, we see that we only have two forces in y direction, which means, and there's only one unknown in that direction, which means we can find one of the unknown or tension in the cable. So this will be the positive direction for our y, and that would give us T minus 50 pound equals 0, and from here we can find the tension 50 pound as well. So obviously if we go with the sum of all forces in x direction, we have two unknowns of A and D, and that's not gonna give us any answer, which means we need to move on to our moment equations so we can find the moment about either point D or A. It won't make that much of a difference. Let's do the moment about point D, counterclockwise positive, and we're going to use the 2D shortcut that we have for finding the moment. I'm going to put the link in the description below if you guys want to check it out, or you just need to revisit to refresh your mind. So the first thing that we have is the moment of 50 pound force about point D, and since that's a counterclockwise moment, it will be positive, and the distance will be from here to the line of from D to the line of action, which is this distance, and we know this is 7 inches. Looking at the next moment, we'll have the moment of T, which is clockwise, so we have a negative sign, and the distance this time will be 7 plus 3, so we know here is 3. And last one will be the moment of A, which if you look at this, we'll see the moment of A is also counterclockwise, so positive, and the distance will be what we have from D to the line of action of the force, which is 8. This will be equal to 0, and we will have 8 times A equal to 3 times T, which is 50 pounds, and from here we can find A, which will be 18.75 pounds. And lastly, we can do sum of all forces in x direction, and this will be our positive. Simply we have A minus D equals 0, and that shows that A is equal to D, and it will be 18.75 pounds too. And no negative sign, that shows that the directions are correct. So for A, we will have to the right, and our D will be to the left. And that would be all for this question. You guys take care, and as always, let me know if you have any specific question that you need some help. We can cover it in the next videos. You guys have a good one, and I'll see you in the next video.